Okay, in this video I'm going to show you some additional Excel techniques that can be useful, particularly if the bond is not trading at coupon date. So if it's going to be a dirty bond, have dirty prices where you have accrued interest mixed into the calculation. But what I wanted to show you is kind of a transition from the pricing model I've used in the previous videos to this new model. So let's start with a simple problem, a simple pricing problem. Up here, what is the price of a bond that matures in 3.5 years and has a yield to maturity of 7% if the coupon rate is 5.5% and the coupon is paid twice a year? So to this point, we've just been using these five boxes over here, and those, by the way I've set those up, they tie exactly to a financial calculator, so it's easy to make that transition back and forth between a financial calculator. And so we're solving for the PV here. Let me go ahead and get rid of the solution and just show you that we have all the inputs. The FE is the face value of the bond, the future value of the bond, so that's going to be the par value, $1,000 for the typical bond. The number of periods, that's what the N is. Because the bond is maturing in 3.5 years and the coupon is paid twice per year, that means we have 7 periods. So we've got 3.5 years times 2 periods per year, so 7 periods. The I is for the yield to maturity. And so again, that's going to be a semi-annual number, a periodic rate number. So because our periods are half years, we're going to have 7% divided by 2, so 3.5% per period. And then the payment, that's going to be the coupon payment. Because it's 5.5%, that means we're going to get an annual payment of $55, but semi-annually, each payment will be $27.50. So I've shown you the calculations there. And if we solve for the price, it's just going to be equals PV, and the rate is down here, the number of periods is there, payments, future value, and we solve for the present value, and we get a price of $954.14. That's negative, and that indicates it would be a negative cash flow that we would have to incur to get this bond. So that's the price of a bond. Now I just want to show you as we transition to this pricing model over to the right, I could spell out some of these things, make it a little bit more clear. For instance, I could put the price, that's basically what PV is telling us in the simple model to the left here. The PV is the price of a bond. The FE is the face value of the bond. The number of years. Now notice I'm making a little transition here. I'm putting in the number of years, and then down at the bottom I'm adding a little row here, a descriptor that says or asks how many coupons there are per year. The yield to maturity, that's analogous to the rate. That's what the I is telling us or asking us for, is the yield to maturity. And then the annual coupon payment is the next row. So I've input in the same information here, $1,000 face value. This time I put in 3.5 years, but I've got my coupon payments of two per year. The yield to maturity is 7%. That's the annual number, and we're going to adjust it with this coupons per year here. And then the annual coupon payment is $55. So if I go up to the price formula here, the PV, now I'm going to have to make a few adjustments within the formula itself. So my rate is going to be the yield to maturity, but I'm going to have to divide that by the coupons per year. The number of periods is going to be here and the number of years, but again I need to adjust that by the number of coupons per year. The payment is going to be down here, the annual coupon payment. Again, I've got to adjust that to be a periodic number, so I'm going to divide that by 2. And then finally, the future value, the face value, is going to be in that appropriate cell. So if I enter all that information in, hit enter, I get the exact same price. I did the exact same calculation. There's just a little bit more description in this middle kind of model. But this far right one is another model, and it's a different mechanism. So let's just talk through what each of these pieces are. The first row here is the settlement date. That's whenever you're buying the bond. The maturity date is when the bond is redeemed or when the bond matures and you get all your money back. The annual coupon rate, that's hopefully self-explanatory. Now the tricky part about this little mechanism here and the functions that we're going to use is that prices and values are all described in percentages of par. So it's no longer dollars, but percent of par. Now remember that par value is typically, in the vast majority of bonds, $1,000. So we're talking about percents of $1,000. And then there's the coupons per year here. That's going to we'll put in the number of periods, and then the yield to maturity is the final input. So all of that is hopefully self-explanatory. Now again, we're trying to find the price of the bond given those characteristics up above. Now what I've done, I've had to now hard code the settlement date and maturity date to make that a 3.5 year window. Okay, so I've picked two dates that are 3.5 years apart. And then everything else I've put in is given in the problem. The coupon rate's 5.5%. The redemption, the face value of the bond at maturity is going to be 100%. We're going to get all $1,000 back, so 100%. Coupons per year is given to us because it's paid twice a year, and then the yield to maturity is also given to us. So the function I'm going to use here in this little bit more complicated model is the price function. So I'm going to put equals price. And once I put that parentheses there, it tells me all the pieces it needs to do the calculation. And so the settlement date is here. The maturity is there. The rate is given in the annual coupon rate. The yield is down here in the yield to maturity. The redemption is what the face value of the bond is, so that's in this cell here. The frequency is given in this cell right here, 2 times per year. And when I do all those things and I hit enter, I get this number, 95.414. Now let's just compare that to the other two numbers that we've got, $954.14 with a negative sign. Remember, the negative signs indicate that it's at the price we're paying, it's a cash flow that's going out. This is telling us exactly the same thing. If we just multiplied this number basically times 10 to get it to $1,000 face value for the bond, so we'd be expressing price in terms of a $1,000 bond. 95.414% of 1,000 is going to be $954.14. So exactly the same output, exactly the same quantitative output, but it's a bit different qualitatively. And you got to remember that we're talking about percentages of par. So that's the price function. The nice thing about this setup here, this framework, is that we can talk about bonds that aren't exactly 3 years or 3.5 years away from maturity. We don't have to talk about bonds that are priced based exactly on a coupon payment date. We can throw in kind of dirty days here, off coupon days, and still get a good price for the bond. So for instance, let's say I bought this bond in the middle of March 2015, and I'm going to redeem it at maturity. So now my price has changed to reflect the fact that I'm closer to a coupon payment, I'm closer to maturity, and it's a little bit more robust from a pricing standpoint than our simple models over here. So that's where this can come in handy, is to get the dirty prices for bonds. Anyway, let's look at this second framework, this second function that we can use. And we're answering here the yield to maturity for a bond. So we want to know the yield to maturity for a bond that's priced at $946.50. And it matures in 6 years if the semi-annual coupon payment is $33. So every 6 months there's a payment of $33. All right, let's go back over here. We've got the price that's given to us at $946.50. Our future value is going to be $1,000. The number of periods is 12 because we've got a 6-year maturity and it's paying coupons twice per year. The interest rate is what we're going to be solving for, and the payment is $33 each time. So let's walk through that calculation. I'm going to solve for rate. The number of periods is given here. The payments are given there. The present value is up here. Future value in that cell. And when I enter this number, I'm going to get the periodic rate, the periodic interest rate, and that's going to be a semi-annual number. So what I really need to do is multiply that times 2 to get an annualized number. And my number, this is a little bit bad form, it's not 8%, but I need to show some more decimals. 7.731% is the yield to maturity, given those bond characteristics. Now this middle column, I don't really like this framework because at the end of the day your formula is very cumbersome, where you're having to go and divide by 2 and multiply by 2 and divide by 2. What may be helpful is to have this more spelled out. Again, I just like these things on the left here because it ties to a financial calculator's keys. But let's look at, and by the way, I get the same answer if it's more spelled out, and I just adjust formulas to get that 7.731%. Let's go over here to the far right and enter in that exact same information. I've set the settlement date and the maturity date to be 6 years apart. The annual coupon rate is given to us. Well, actually, we have to infer that. The coupon payment is $33 every 6 months. That means it's $66 per year. And if we divide $66 by the $1,000 face value, we would get an annual coupon rate of 6.6%. The bond price, we're given that as $946.50. I need to express that in percentages of par. So because par is $1,000, that means the price is 94.65% of par. The face value is $1,000. There's 2 coupons per year, and I'm going to solve for the yield to maturity. And here the function I'm going to use is yield. And again, it tells us all the inputs that we need. So settlement is there. Maturity date's given right below. The rate's there. Price is here. Redemption, that's the value that you're getting at the end of the day. And then frequency is going to be 2. If I enter all that information in, I get the exact same answer. Let me just format it. I get the exact same numbers as before. So a different pricing model. The bad thing about this more explicit model on the right is that all you can solve for is price or yield to maturity. We can't solve for the coupon payments. We can't solve for the number of periods. We can't solve for the well, you never solve for the future value anyway. So we're missing the functionality that we have with the very simple model on the left, in that we can solve for basically all of those things. We can solve for price, we can solve for the number of years to maturity, we can solve for the yield to maturity, and we can solve for the payments. So anyway, I just wanted to expose you to this other model over here. It'll be in your textbook, so it's handy to know that as well.
Say now, you said it to me. Sorry, do now, you did it to me. Toli tolu baja raj raj ke, o sayar manana